Um, Hi there, I'm Farlek, and thank you for attending Spark Execution Plans. A little bit about me. I'm a principal consultant at Advancing Analytics. I work on Azure, Databricks, and Terraform projects, and I have a real passion for automation and making sure things work really well to make my life easy. I'm a Databricks champion. I've and have loads of different certifications. Feel free to come and talk to me about them, and I'll give you some tips. So, what are we going to talk about today? So, we talk about Spark optimization, and it's quite a daunting thing to talk about because no one really knows what's happening. So, under the hood, what's really going on? And so, it's daunting. Where do we start? How do we understand things? How do we read it? And so, hopefully, I'll be able to kind of give you some tips on that today. So, Spark Execution Plans is a really handy tool that will allow you to look at the plans that's going to get executed on your cluster. And it's a way to kind of efficiently identify the steps it's taking to and the processes it's doing to execute your operation. So in this session, I will go through how we can read, how we can understand these plans, also look at the execution flow, so you understand actually what's happening with these when you send us a code across onto your cluster. And then there's other techniques that we can use to further optimize these plans, and we'll have a look at adaptive query execution. And then we'll also look at the Spark UI and see how we can utilize that and look at the plans, the usage, and a little bit about that as well. So to start with, let's have a look at the execution flow. So no matter which Spark application you use, so be Synapse, be Databricks, it's always going to use what is called the Catalyst Optimizer. And this is basically a way to discover the most efficient plan that's going to execute your Spark operation. It looks a bit like that, and that's quite daunting. It's a massive flow. Loads of things are happening there. There's logical plans there. There's physical plans there. There's a bit of a cost model in there. And then it's another plan there, and then it executes. So essentially, we can break this down to smaller things. So you have a valid bit of code, and that code goes and becomes a logical plan. And there's a few different logical plans, but that logical plan will then get optimized. Then it will become a physical plan, then it will get executed. So essentially, that's what's happening. So let's drill further into that. So the execution plans, we have a logical plan, and they're broken down into three. So you've got the unresolved logical plan, you've got a resolved logical plan, and you've got an optimized logical plan. And then that becomes your physical plan. And there's multiple physical plans, so there's multiple strategies that's generated from these optimized logical plans, and the best one is chosen. So by drilling into this, so we've got that first one, that unresolved logical plan, or known as a paused logical plan. And this is basically, once your code's validated, it will basically look to identify all the objects you've got. And anything that it doesn't identify, it will flag it as unresolved. So we've got there an example, it's not been able to resolve my relationship. So then it will basically go and try and resolve that, or analyze logical plan, called, and it will try and resolve these attributes and relationships by using the catalog metadata repository. And this is the Spark metadata that is captured. So all your data frames, all your tables, anything that you're running is basically stored inside your metadata, and it's going to use that. And then once it's resolved your attributes and relationships and objects, it will then go and optimize it. And this is where it's going to apply all of your predicates, your rules, your sorts, your expressions. All of that is now going to be applied, and it's going to try and optimize that. And that's what gets result into your physical plan. So now we've got a logical plan, and then that physical plan will generate multiple strategies of how it's going to execute. So these are different ways it can execute that plan. It will go through the cost model. The cost model is going to establish it's going to try and estimate and establish the best execution in terms of time, in terms of utilization of your resources. And then from there, finally, it's going to pick one plan. So it does a lot of steps, and we don't see any of these steps because it's so quick, but it is going through all of these steps. Your physical plan looks something like that, and we'll drill into these in a sec. So to generate your execution plans, there's a couple of ways of doing it. You can use either Spark, SQL, or you can use Python. And both use the explain function. So you either have a data frame and you do explain, .explain, or you do explain, then a SQL query. And both will result into giving you the physical plan. So without any arguments, it will give you the physical plan. If you apply an argument to it, so you can have true or extend, it will give you both the logical as well as the physical plans. And then there are also other commands that you can apply to it. You've got CodeGen, which is basically going to give you the physical plan, and it's going to show you the code that's generated underneath it. That gets sent to your application. There's also cost. And cost is basically where it's going to look at the statistics, and it's going to bring back the statistics of what all those steps. And then there's format. And formatted is basically where it's going to take your physical plan, and it's going to give you a summary of the steps. And then it's going to detail out those steps later on for you. So let's have a look at all of this. And my laptop's turned off. Right, so I have run this before the session to make sure that the cluster didn't turn off or anything. So there's three things we'll look at. So we'll look at reading a basic data frame execution plan. And so we'll look at the logical and the physical, how we can generate a plan, and then we'll look at a little bit more complex data frame. After that, we'll also look at a delta table, and we'll see how we can read a delta table and look at the physical plan for that. And then we'll see some of those additional commands that I mentioned. So here, firstly, all I've done is created a database that I'm going to store my tables in. And firstly, to generate a basic data frame, all I've done is gone through a range between 1 and 1 million, and created an ID, a column in there, and just said times 10. And that's going to give me there's two things happening there. So it's giving me a range, and it's doing an aggregation. Give me an ID. And so if we look at that, that looks like 1 to 100, or 1 to whatever, it goes to 1 million, and there's my data. So that data frame, if we put the true command onto it, and so we send a data frame, we do .explain, and it's going to give me the plan, the logical plan, as well as the physical plan. So if we try and break this down and try and understand it, we've got 2 steps here on this first bit. So we've got 2 steps. So the first step is it's looking at the range. That's the first bit of our query at the above, and it's gonna do the range. What the range of that is between 1 and 1 million. The step. So this is what it's going to increment it by, and then we have split, which is our the partitions that it's using for that part. Oh, better. Okay, yep, so that was the first bit. Next is the analyzed logical plan. And that bit there is basically very similar, because this is a really basic data frame. So it's not doing a lot more. It's got a project. So project is a mathematical term for select. So it's a way to return back return the columns that you're trying to view. And so it's selecting the column that we've got. And then it's also analyzed that actually we can cast the integer that we got in there, timesing it by 10. So we've got the column, the ID that's timesing by 10. And then the optimize, again, once it's optimized, it's actually realized it doesn't need to put the cast in. So it doesn't use it at the end in this bit. And then we've got our physical plan as well that's laid out there. And it's just the 2 steps that we've got in there. So there's not a lot happening. So we can do explain, and if we do explain on the data frame, it's just going to get our physical plan. So again, it's just the last step of what we saw above. So if we start trying to put a bit more detail to it, so if we repartition it now, and let's see what happens now. So we've repartitioned it by 6, and then we'll do explain again to get the physical plan. And this time it does the same thing. So we still got our range, it's still got that first bit of our data frame. Then it's got the project on it again. But this time it's started doing an exchange. So exchange is basically a way it means it's going to shuffle it. It's going to shuffle that data for us. It's going to also do a round robin partition. So partitioning is one of the strategies of partitioning, and round robin is one of them. And it's going to do it by 6 because that's what we've defined. So it's doing an exchange and it's doing repartitioning. So it's doing a shuffle for us on the data. So that's what we can see that it's doing. So if we make that a bit more complex, what we do is we'll create another data frame. And this time round, we'll have 1 million records, but this time we'll increment it by 5, the ID. We'll repartition it by 8. And then we'll join the two together. So we've got the data frame at the beginning that we had, and then we'll have this second data frame. We'll do a join, and we will also do an aggregation. So we make it a bit more complex, more steps to it. And this time around, when we do the plan, we get the physical plan out, we can see it's a little bit bigger. And this is it. This is the tend to be this kind of size of queries we'll look at. And this is where it starts getting daunting because we've got a lot here. So how do we read this? So the first thing to note is we always should start towards the bottom. So work our way up. But not necessarily the bottom one's going to be the first step. So the execution order is these numbers. So it's always worth looking out for the numbers. So that's actually the first thing it's going to do. It's going to do that step there first for us. So it's going to do the range, it's going to do the partition, it's going to do a bit of shuffling, it's going to do a bit of repartitioning. Everything we've said, we wanted that data frame to do. And that's the first step. And then the second step is our second table or data frame we've got, and it's going to do the same thing with that. It's going to do a range, it's doing a project, and then it's doing a bit of a reshuffle, and then it's repartitioning. And then once it's got the two data sets here, it's going to then do a broadcast hash join. And broadcast hash join is basically where it's going to take the smaller data set and it's going to put it on the same executor as the larger one. And then that means we don't have to kind of do as much shuffling. And then it's going to then just rejoin those data together. And then it will project out the output of all of that. And that's what that project is. That's that select. It's selecting out the output of those two data frames joined together. And then we've got our hash aggregation. And this is basically where it's going to add, do the calculation we got. We've got an aggregate in there, so it's going to aggregate that together. But it's only a partial one at the moment. So you can see it's a partial one. So because if we have multiple joins and there's multiple steps that it's going to do these aggregation, it'll do the aggregation again later. So once we've got everything, there's another shuffling happening to make sure that everything's in one place. And then it does that final merge aggregation at the top. So that's the step 4. And that's a lot there's only 4 steps. So that code actually is only just showing you 4 steps, but it's a lot of lines of data, or a lot of line code there. So next what we do is we'll have a look at Delta. So Delta is some Spark tables that are going to be loaded in. And it's a way to help build in reliability and performance optimization in it. So we've got some physical tables that are some Spark tables that are pointing to physical Delta files in our lake. So here I've created a couple of tables, and it's going to be, one table is going to be 30 million, and one's going to be 1 billion. So we've got a sales table that's 1 million. Sales table that's 30 million, and items table that's 1 billion. So it's just simply creating a table for me, some Delta files, and it's going to store that in my in my lake. And then we'll create we'll create a data frame with with a select statement and some aggregation and some join. So we've got here, we're doing a select on the date, and we'll aggregate the quantity and the price. We'll do a join between the sales and items table. We'll also put a filter in there, and then we've got a group by and order. And so we'll create that as a Delta data frame, and we'll keep that in there for now. But before we look at the data frame, let's try and run SQL against our select statement. So we can just write SQL, and we can write the select statement, and it will output some results. And if we want to use the explain facility using just SQL, we can do, and it will give us the plan bit underneath it. The only thing with that is it looks horrible. You can't really read that unless you output that out into a notepad. And again, that's another step. So I'm not a massive fan of the way the SQL outputs that. So that's why I have the data frame. And so if I do the same thing in the data frame, explain, extend, it's a much nicer and clearer way to read it. So now we have this data frame, which has our SQL statement in it. And if we explain that out, we can see what's going to happen. When we run that query, what is actually happening. So the first thing it's doing is that kind of the unresolved logical plan. And here is a bit more. So this is where it's saying, actually, it's not been able to resolve my relationship. And it's not been able to understand what that alias is, which is why it's unresolved it. So it's not. So the next step is what it's going to do. So we can see here that it's trying to build that join, but it's not been able to resolve it. It's got a filter. It's got some aggregation that we've applied to it. And then it's got a sort, again, because we put a sort in it. So the next step is that analyze. So what is that doing? So then it goes to that Spark catalog that we've got. And it's going there and it's getting the metadata and it's going, okay, this is what you're trying to see. This is what the alias should be. And this is how it should look like. So that's our sub-alias. So I actually stands for that. It's bringing back some of the columns from it to realize it's Parquet. Because though it's Delta, it's still saved as a Parquet file. And then it's doing the join, and now it's applied some filtering again, and then we've got the aggregation, and we've got sort. But also this time, as it's done the analyze logical plan, as it's tried to resolve it, it's also identified some casting that it might want to do, might want to apply. So what am I understanding from this is, actually, if we had our source system and we had better data types in our in our source system, or we defined our relationships better, it wouldn't need to do these extra steps. And then the final optimized plan is there, and what it's now done is here is it's actually brought down the filter. It's brought it down because it's identified as a part of the optimization of it is I can get the data and I can filter it before I join it. And that is actually better performance, because why would you join two bits of data then filter it if you have the ability to filter it beforehand? And that's what it's doing now. So it's brought the filter down a step, and you've got the project again. So it's going to select out with the filter, and then it's going to then do the join, and then it's going to project it out, and then it's got your aggregation again, and you've got your sort. So if we look at the physical plan, we'll go down to it, and we'll just do the explain, and it's the same thing, but we'll just get it out separately. And we go down to the bottom. Oh, I'm going to zoom up a bit. There you are. We can see that it's a lot longer because we've got this file scan at the bottom. So again, that's not where we're going to start because that's number 2. So we're going to start at number 1. So this bit here. So we can see that first it's doing that file scan because it's a Parquet file. So it's going to go to my lake. It's going to get my file. It's going to get all of the data types for it. It's going to get anything that it needs to. So any partition filters I might have on it. And it's going to bring that back. And then it's going to apply that filter. And that's my first step. It's going to get the data. It's going to apply the filter. And then the same with the second bit of my data. So the second table I've got. So that second table is my items table. So again, it's going to go to my lake, it's going to get it, it's going to put the filter on it, it's going to do a sort as well. And the reason why it's doing the sort here is because this time round, when I do my, when I join my data set together, the two data sets that I have now, it's going to do a sort merge join. So sort merge join is another join type. And this is basically does it in two phases. So now it's going to do, so it's too big to put it onto the cluster. So it can't do a broadcast because they're too big data sets to put in memory. So it's going to do it in its own separate executors, and then it's going to then sort it in its own executors, and then it's going to join it together. So that's what it's doing here, and that's why we have this a sort there. Also, it's also doing an exchange in here. So it's also shuffling the data on the executor. So it's bringing back the data, it's filtering it, it's doing a shuffle, and it's sorting it. And then finally, it's outputting everything to get out. It's outputting it all, and it's saying this is what everything that you need to bring back. So we've got the quantity, the sell date, and price, and they're the three columns that we need. And if we go further up, it's then going to do the hash aggregation. So it's doing a partial one because it's only half. It's not ready to do the full. So it's going to just do it up to that point, and it's going to aggregate it. It's doing another exchange. So now it's shuffling that data, and it's doing a hash partition. Now with that, it's just using the default 200. So it's just using the default partition number. So this is an area that we could look at improving. If we know that it's going to happen, then we could force it to do a reshuffle or do a shuffling, but based on our criteria, our needs. We could change that to 8 or however many partitions we want it to be. So it's an area that we could look at improving rather than using 200. And then it's finally going to do your aggregation out, and then it does another exchange. Has anyone been counting how many exchanges I said? So there's about 4 exchanges. So it's shuffling the data about 4 times. This is what I mean. We could improve that. Do we really need to move the data around and shuffle it so many times? We can look at improving that. Finally, the last output. Yeah, the last output is basically does another exchange, and it's doing a range this time. And this is basically where it's dividing the partitions by a sort key, and it's going to then, so it's taking everything we've got now, and it's going to reshuffle it, put it in order that ready for our sort. No question. First question there is, in case of real complexity queries, is there a way to redesign the execution plan manually for further optimizing it? Not sure what we mean redesign, but you can tweak so you can change the way the sorts are happening. So if you want to enforce a different type of join, you can enforce that. So if you want to not use which one did I say appear? Sort merge join, and you want to broadcast it, you can change that in your query, and you can change the partition type. So if you want to partition in a specific way, you can change. So I don't want hash partition. I want another type of partition. You can enforce those. So. Yes. Yeah. So the question is, has there been a time where the optimizer has chosen the wrong plan? Of course there has. The optimizer is not perfect. It chooses the wrong plan a lot of times. Sometimes it depends on the cluster size. If it thinks that actually the cluster can handle it because it's got enough memory and all that, it might choose something. It does. It's not perfect. So there is an optimization option with adaptive query that we'll discuss that helps with that. and that's what uses it. But this is where, yeah, you can do query hints. So you can enforce the way you change the plan. So if you know the plan, so there have been times where we've looked at it and gone, oh, it's doing a sort merge. I don't want it to do a sort merge, or I don't want it to do broadcasting because it's too big. Then you can use the query hints to enforce it to do a certain type of join or certain type of partition. So yeah, it's not perfect, I'm afraid. The bottom question there is, are you able to get the notebooks? I'll put it on GitHub, and I'll show you my details later, and I'll get that on GitHub at some point. All of this. Okay. So any more questions? No. Okay. So we've looked at some delta. We've looked at a delta table there, and we've tried to explain some of the steps that's happening on that. Okay. So then we've got Spark UI. So Spark UI is essentially a really useful tool, and it really is good for kind of debugging, identifying, where you can help you identify performance issues. And it has all your queries, your jobs, your DAG. So the DAG is basically your visual representative of the execution. It's got your query plans in there, and it's a real good insight to what's been executed. So obviously, you can never trust live demos. I've got some images here of the jobs, and we've got an image of the DAG. So these are all the steps. I'll go into the plan the UI in a second, and then you can also view the exact plans that we're looking at now in the UI. I thought I had a link, but I don't. So to get to it, we would need to go to the cluster page. This is why I have the images, because that is taking longer than it should. And it can be a daunting place to start, because it's very... oh, it's turned off. That's probably why. That's not going to work, because it's turned off. So it's lost the stuff that I executed. So it won't be there. But I will explain it in a bit more detail. Go on here. So jobs. If I can see it. Yep. So jobs here, you can see that you've got details of went too much. Yeah. So jobs is going to just show everything that you've ran, and you can feed through them. It does break it down quite a lot. So it is, anytime you do any little bit of, there's a drop there. There's also some optimizational stuff that's happening on the cluster, and then it shows everything. So it can be a bit daunting to find where the task that you've executed, the job you've executed. The tab that we're more interested in is in the SQL and data frame one, which shows us the DAG, and this is basically all those steps that we looked at in the plan, but in a visual way. And it's not perfect, it's not amazing, but you can drill down into them and see things like row numbers that it's been using, the stats behind it. And if you've used Databricks and you've used Databricks SQL Data Warehouse, the query profile out there is so much nicer. And they will hopefully one day they'll improve this. But the Spark UI is available no matter what type of application you use. So be Synapse, be Databricks, you have got this Spark UI. The other thing you've got is the query plan is also outputted there. So you've got basically the exact same query plan that we've been able to run, and it is available to see in the Spark UI. Okay. Don't know why I did that. Right. So I mentioned about adaptive query execution. So what is that? So this is another way to further optimize those execution plans that we saw. So your plan that's going to be executed is another way to optimize the query plans. So this is something that you have to switch on because it's not available as default. So you have to change the Spark configuration settings. to be able to view this. So essentially what this is going to do is going to change your plan at the time of execution. So it's going to basically use real-time statistics to determine a better approach of what it might have thought it was going to do as part of that physical plan. And so it's basically, and essentially, because it's now got the data and it's now knows what the data size is and what it looks like, it can change the plan. So the example there is, it started with the initial plan said it's going to do a sort merge, and that's what it sent to the cluster. But as it loaded the data, it's realized actually it's small enough to just do a broadcast hash join. So it's done that, and it's changed it, and it changes it at the time of execution. And this will increase the performance and make your queries faster and better for analytics. So it is visible in the Spark UI, and you can view it, and you have to hover over, and it'll tell you if it's switched on or not. It's also visible in your query when you use this explain function, and it tells you if it's been used, if it was a adaptive Spark plan. And as I said, you have to enable it. So you have to use the Spark configuration settings. And this is really useful when you've got slow running queries. So things that got a lot of shuffling happening, a lot of joins, the skewed data. So the data set that I used was a skewed data set because it was in a small cluster. I ensured it was on a small cluster to enforce it to not do a broadcast join. But something like that, if I used adaptive query, it would have tried to do the broadcast join. Am I doing? Oh, any questions? Oh, is there a downside to using adaptive query? Hmm? Well, there's the downside of using adaptive query. Obviously, is you're going to have a cost because you're going to have a certain type of cluster as well to make sure that you're getting the most optimized of it. But yeah, that's the main downside. But yeah, you should try and use it, but it's cost as well. So it depends on if you want to put that in. So there's one over there. So what happens with the adaptive query when you turn the cluster off? So with all of these execution plans, it's at the time of execution. So once it's been ran, it's not persisted anywhere. So if you want to output that out, you could export it out, but that's with all the plans that you generate. It's not, none of that's saved anywhere. It is at the time of execution, which is why my cluster's turned off. If I go back into it, it'll be empty. So there's no point me sitting here for 5 minutes turning on my cluster because there'll be nothing there to show. I have to run it all again to be able to show you what that would have looked like. Yes. So yeah. So when you're running, so the question was, is it useful to use when you're using it for repeatable processes? Yes, it is. Yeah. So it would be good if you've got something running on a daily processing, then yeah, it's very useful for that. There was a question over here. Yes. So is it you have many users? Is it better to have many clusters or one cluster with a big cluster? Again, it depends on the needs. So you're better off to have multiple different clusters for different needs. So if you've got analysts who are going to do querying, you might want to give them a smaller cluster. If you've got processing happening, you want to have that big cluster because to get it process all your data. You might have a different cluster for your ML needs. So it will all depend on the type of needs of the cluster. So you've got serverless as well, which might be useful for your analytics because you want to switch on quickly, you want it to run, and then switch off as well. So it will all depend. It's not as straightforward of have one big cluster and everyone use it, because you're still gonna have similar problems. And plus, you're going to be wasting money on big clusters when it doesn't need to be running, especially if you've just got one little select query happening throughout the day. So, any more questions? Yeah, but no, no. Oh, okay. How can we control? How can we control SQL shuffle when writing into Delta? Yeah, I have no idea. I have no idea. I'll read the question afterwards and try and figure it. Yeah, I'll have to read the question. Sorry, I can't, it's not. Yeah, I'll read the question afterwards and answer it. Yes. Yeah. Yeah, that's the bit I forgot to show you, Sam. So thank you for reminding me. I'll show you the statistics. I knew I forgot something. All right, so the statistics one. So the question is what does the statistics? What does the plan look like when you have the statistics? And so I'll go through this bit. So I've got the additional explain functions that you can apply, all the parameters you can apply. So the extend, we mentioned extend. That shows you both the logical and physical plans. Oh, my laptop's turned off again. And next we've got is the CodeJet, which is basically going to show you the code underneath it. And so this is not hugely useful unless you know how to read it all, but this is what's going to get sent to your Spark applications. And all it is you've got two ways of doing this. So you can do explain mode equals and then apply the argument, or you can just put the argument in, so the mode is no longer needed on them. And then the cost is the one that's going to show you the statistics. And it's not a huge amount of statistics. The question was, what does it show you? It doesn't show you a lot, but it does show you like the sizes of them and as it goes through the process. So again, not sure how useful it will be, but it shows the size of the data that's moving up. Now, this is a lot more, you can visualize this a lot better on the Spark UI using the DAG than you can on here. I think on that, it shows it a little bit clearer, the kind of the size of the data. So it's also got rows. So some of the number of rows, it's joining. So sometimes you can go from 1 million, and if it's then joining again, it's become 2 billion. You know, something's happening there. You've probably not got a join right. And then we've got format as well, which is basically shows you all the nodes, shows all of the steps, and in a slightly clearer way. So it's not as messy because it's not got all of the detail underneath it. And then it has the details split out. And again, it's a little bit clearer. It tells you what all those steps are. It gives you what's happening in each of these steps. But it doesn't give you that same flow as what would have when you used extend. Okay, so we've got a couple of minutes, so I was going to just go through query hints quickly, unless someone has any more questions. All right. Does that catch up? Yeah. So, mention query hints. Yeah, so mentions query hints. So this is it's a way to change the generate execution. Sorry, it's a way to change the execution plans when you execute your SQL query against it. And it's quite simple. And I don't know why the colors come up that color, but it gives you can have partition hints. So there's two different types. You've got join hints and partition hints. So partition hints allows you to change your partition strategy. So you can change it to color cell, repartition, partition by range, and rebalance. And you can basically change the way it works at the time of you executing that query. So before we do our select style, whatever it is, we can change the way we're going to make sure that's partitioned. It's really useful. I think I mentioned a few minutes ago when the query planner is doing things in a specific way, and you don't want it to do it like that. So it's quite easy to add. You just basically put it in. You put it in which type you want. So if you want repartition, and then the number that you want to repartition it by, and that number could be, well, the n is actually the column as well. You could use a column to do it. So you could say based on a specific column. The other type you've got is basically where you've got the join hint, and this is basically changing the join strategy. So again, if you don't want it to be a broadcasted, or you don't want it to be a merge sort, or you don't want it to be shuffle, then you can change that. And that one, you would basically do this. It's a very similar thing. You would basically do before you list out all your columns, you would define the strategy, and then you would basically say what the table key is. So the key to it. So, there you are. There's the info. Okay, so that was the partition hints, and that was the join hints. Cool. Any questions? All right. So I'll go to a recap, and we'll just run through them. So execution plans, it's a good way to help you optimize your queries that you're running. We looked at the logical plans, the physical plans, how the flow, what it works, how it goes end to end, how to generate them, how to read them, using the explain function, how to read it backwards. So you not necessarily from the bottom, but work your way from the bottom. Use the numbers and the brackets. That'll help you understand the order, the execution order. We also, explained explained exchange. Exchange can be an expensive operation. So, if you can limit that, then that's an area that you will improve. Things like defining your partition, your joins, the data types early on, or even at the time of execution, will help you improve your query. If you determine what you want it to be, it will improve it. We've got additional parameters that you can apply to your Spark executions plans, which will give you different formats. Things like extend, format, code gen, cost. They'll all give you different outputs. We've got the Spark UI. It's a useful tool. It's got a lot more than the stuff I was talking about. It does give you a lot more detail about the actual executors as well. But it's a great place to get the details of your plan, the general usage. Obviously, you've got the DAG as well. That's a really useful tool. We've got the adaptive query execution, which will help you further optimize your query plans by using the runtime statistics. And that's very useful. So it's worth turning on if you have the ability to do it. So I would say just try it. Next time you're trying to understand your query, try it out. Hopefully you've got a good understanding now of how to read them. And the more you read them, the more you'll get clearer on it. Check out our site and YouTube, and I'll put the slides and notebook on GitHub at some point, probably next week. Anyone got any questions? No? Thank you.